Hi everybody, I'm here with Heather Miller. She's the director of the Scala Center at the Swiss Federal Institute of Technology in Lausanne, also called EPFL. And actually we ended up in Basel in a little hotel lobby because she works sometimes from home, which is in Basel, and also myself, I work sometimes from home, which is also in Basel. It's the reason why we are here in Basel. So Heather, can you maybe tell me a bit about your profession, your PhD, how all gets started in the Scala Center?
Yep, sure. So maybe I can hold this. Maybe.
Okay.
It's probably easier.
Okay.
So I did my PhD on Scala, and I did it with Martin Oderski at EPFL. And I did it at a time when Scala was getting really popular, so I was always kind of around to see sort of the growing pains and sort of the successes and the failures that we've had as Scala was just getting started. And at the time that I finished my PhD, there was a real need for just a third party to make sure that things that were not super attractive that needed to get done would get done somehow. So an example of something that maybe one company or one person on their weekends wouldn't really want to do is developing something like an index of the entire known ecosystem of libraries that are published in Scala for different versions of the language and things. And this is something that we spent a couple of months building, and it's something that turns out to be super useful for people just trying to build basic projects. So lots of things like this where it's not like the new cool thing, but it's extremely useful and everybody would benefit from it. These are the things that the Scala Center focuses on.
Okay, so you told me you have a couple of employees and all those employees are developers. So can you tell me a bit, besides creating that famous index, what they are doing all day long?
So they're doing lots of different things, and many of them have multiple projects. So it's difficult to say even just one area of things that we're working on, but we work on things like SBT right now. So we've made a bunch of improvements to SBT in the last few months. We're working with the team at Lightbend, which is 2 people. We've added basically 2 people full-time at the Scala Center for the last few months to help them make a bunch of changes, make SBT easier to use, make SBT faster, and to get the 1.0 release out sooner. So that's one thing. Another thing is making it easier one day when Dotty appears, or Scala 3, or whatever, whenever it happens, to make it possible for people to actually upgrade to it if it does happen. If it doesn't happen, if anything, whatever happens with this Dotty project, it's still difficult to upgrade between different versions of Scala, or even to upgrade libraries when you upgrade to a new version of Scala. So we've been developing migration tools, for example, to make it easier to migrate between different library versions or Scala versions or whatever. There are these rewrites, these very intelligent rewrites based on abstract syntax trees that this tool does. So we work on this, for example. We're working on, we built this thing recently called Scasty, which is basically running Scala in a Docker image on a server at EPFL, but it lets you try any library, any compiler version, so anything from Scala 2.11, 2.12, like standard mainline Scala compilers, to even stuff like Scala.js, Scala Native, or Dotty, or the type level compiler, so you can choose any one of the sort of Scala compilers that are available, and then any published library for any of those Scala compilers. And you can do it all from the browser, which is really nice because it's a good way. And it's kind of like if you know JS Fiddle, if you go on Stack Overflow and you ask, how do I do this thing in JavaScript? There's 20 people responding, oh, I did it here, here's a little fiddle. And you click it, and then you can actually play around with it in the browser and see the style sheets and the HTML and the JavaScript that somebody wrote to do something. It's the same idea, but for Scala, and it lets you use any library that's published. So it's really cool because it's useful for maybe if you have a certain library that you've published, you can your users can recreate bugs, for example, maybe some interaction between your library and another library, and it can all just be linked to in the browser. You can save it and share it. We work on lots of things like this, so it's really difficult. It's not one category of, we work on tools. We're working on another thing that we're working on that's totally different is the collections library. So we're rebuilding a brand new collections library with Martin Oderski and Stefan Zeiger over at Lightbend. So together We're replacing the Scala collections library, so that's something extremely core. And we're maintaining the processes for evolving the language in the library. So there's the SIP process. We're getting changes into the mainline compiler via this process, and we're also trying to develop something called the Scala platform, which is sort of a group of mature libraries that people should get as like the Scala distribution if they sit down and want to use Scala. So it's really a ton of stuff. Community things, tools, central libraries, central processes, compiler work. Yeah.
Okay. And who is using Scala? You have any idea?
A lot of people, and so it's best to say that a lot of industries are using Scala, and it used to be that there were companies that built web apps that were using Scala. So, Twitter was famous for this in like 2007, 2008, but since then it's really spread to totally different industries. So you have like newspapers using it, The Guardian uses it, a lot of the banks use it, IBM uses it, Spark is built on it, so it's sort of a popular language in this big data space. It's being used for all different sorts of applications, from big data streaming sort of stuff to making websites and very resilient sort of web apps and things. So it's a very multi-purpose language.
Okay. Do you think ApacheSpark would have been so successful without Scala?
So it's a good question. Now that there are lambdas in Java, it's like, okay, well, maybe we could have built it with Java 8, right? First, it predates Java 8 by quite a bit, but there are still some things that are a lot nicer about Scala that Java 8 doesn't really have. And I mean, it's a lot of things from, the syntax being more concise and things like pattern matching being possible. These things are all sort of important to the actual core implementation of Spark. So if you look around, they're using a lot of these things, and it makes it easier to build something like Spark. And these are features that now that Java 8 has lambdas, Java doesn't have these yet. So there are many things about Scala being a functional language that make it still more convenient to write, especially big systems in. So you can basically write more meaningful code that does more in less time effectively, and obviously also less lines of code. So Matej Zaharia says that he needed Scala to do it mostly because of the functional features of the language, and as you can see, Spark has a rather functional interface as a result of that. Yeah.
Okay. So one of the optimizations Spark does is whole stage code generation, and I think in Scala that's pretty easy. Would have been possible as well using Java?
That's such a funny question. So if you really want to do some analysis, generate some Java code or generate some Java bytecode, I mean, if you're the kind of person that's going to be doing whole program optimization, there are very researchy things that you can use to achieve it. So it's not impossible for sure. Spark makes use of a lot of things, so they're not just only using the Scala, like the features in Scala. At one point they were, but as far as I know nowadays, they're using more and more things they're generating Java code. I'm not sure how much of it is depending on sort of the Scala language features for metaprogramming, but they are very heavy users of the metaprogramming capabilities in Scala. So we know them as macros, but there are all kinds of things in this category of metaprogramming that the Spark folks use to do this optimization. So it's not macros only, it's lots of stuff.
Okay. So if I'm a Java programmer, what's the best way, first of all, to motivate myself to learn Scala, and what's the best way to learn Scala?
There's two arguments. I mean, there's technical arguments, and of course there's like social, financial ones. So on the technical side, what people like about Scala a lot is the fact that you get type inference. You have to write a lot less boilerplate code to do simple things. Like you can write just class, whatever. You don't need a bunch of constructors. It's just less code, and you can more sort of concisely express your ideas. So people really like that. And when they have to go back to Java, they get super complainy because they realize how much less they're writing nowadays. So people feel that Scala is a lot clearer to use to express your ideas, and that you have to write, less typing cycles, basically. And in addition to that, the fact that you don't have to actually write out all the types, it's nice because we have type inference, so we can not have, it's a little less to write on that front. And on the sort of social, societal, financial side, there's currently a bunch of industries taking Scala up right now, which has driven it extremely into the, low supply, high demand category. So right now it's pretty advantageous financially to be a Scala programmer. I think in 2016, it was the Spark and Scala were the highest paid jobs on the Stack Overflow developer survey. Oh. So that's like a nice incentive, I guess. But the demand is certainly very high, which is a good reason to consider learning it, I guess.
Okay, so the second part of my question is how do I actually learn? How do I start? For me, as a Java programmer, it looked really weird, the syntax, so I had to take a course on that. So any recommendations there?
Yeah, so there's a bunch of recommendations. It depends on your style of learning. Some people are like, I just want to quickly just get up to speed so I can just start writing something. And if that's you, then there's a book called Scala for the Impatient that's really useful. And you can just it's super concise, and you can just look at things like how do I do this Java thing in Scala, or like what are the features I should know about maybe. So that's a lot of people like that as a really fast introduction if you're already a Java programmer. If you feel like functional programming or these ideas are kind of hard and very exotic, and you have really no exposure to these things, I would recommend maybe something a little more in depth. So there's this Coursera course called Principles of Functional Programming in Scala. It's a few weeks long, and it takes has each week has a few, like an hour and a half or so of lectures, maybe a 2-hour assignment. And you could probably do this over the course of a couple of weekends, but it's more in depth than maybe picking up a book and looking at it for a few days. But it's super thorough, so that's a really good one if you want like a serious introduction. Otherwise, if you want to just get your hands dirty and not go buy books or not deal with these online courses, there are 2 more resources that are very nice. So one is called scalaexercises.org or .com, and basically it's a bunch of in-browser it's kind of like you're writing unit tests, but you're learning the language features, or the features of the language as you go. So you're learning what certain things do by guessing what the result would be, and then you have to interact with the tutorial and type it in. And finally, there's a book. Actually, there are a couple of books by the folks there's a consulting company called Underscore, but they've made all of their books open source and free. One that I like a lot is called Creative Scala, but they have a few more, and it's a really nice sort of. They teach you everything that you have to do to get Scala going on your computer, and then it's a very visual introduction to Scala. So if you're also not the kind of I want to implement a little calculator or something, it's basically you're learning functional programming concepts by making visualizations and generating pictures and things, and then you can see how some functional idea, translates visually, so you see like the algorithm kind of visually. It's really cool, and I'm a visual learner. I think that one's fun. Yeah, those are my 4 recommendations.
So maybe addressing the data scientists a bit more, we have been talking about Spark. So it was the case that for Spark, the Scala programs have been the fastest. And since the new data frame API and also the Catalyst Optimizer and Tungsten, I think that's not anymore the case. So what's your recommendation, when to use Scala, when to use Python, or maybe R in the context of Spark?
Yeah, so that's kind of like a 2-pronged answer to that question. So I think that there are sort of 2 groups of people that kind of fall into different categories that would like to learn Spark for data science. The people who are typically setting up pipelines, and maybe these pipelines have to be, very rich and doing things online and whatever. People who have a tendency to be maybe a little bit more on the systemsy side, then they should definitely be using Scala. I mean, it doesn't really make sense to use Python in this case, because you're going to run into all kinds of little headaches between how to introduce sort of the Python APIs and the whole Python thing into your whatever not Python ecosystem probably. The other side, the other people who should be considering using it, that maybe should use the R or the Python side, are the people who are trying to do maybe like one-time visualizations. Like I'm going to explore the data, and I'm going to just, I have a big data set that I can't represent in memory, and I want to interactively query it or do some algorithm on it and sort of get some interesting insight out of that data. But I don't have to do it every day for the next 6 months or something. It's just a one-time thing that I need to show a chart to some organization or publish it somewhere. This is when probably Python and the R front ends to Spark make the most sense, only because you can sort of stay in R and Python. You can get these results out of Spark and then immediately just like pipe them into whatever framework that you want to use for visualizing those results. And it's a little difficult to be thinking in Scala or something and then now you're going to have to use R to visualize it. Like you can stay all in Python or R, so long as it's not going to be like this pipeline running for days or something. I think that these are the 2 main use cases.
Okay. So we've talked about you and your center. So do you know what Martin Odersky is doing all day long?
Yes, he does lots of things, but the thing he likes the most is hiding and working on his new compiler. He's a professor, so he teaches, he sits on PhD committees and all kinds of things. He's got lots of things to do, but if he didn't have to do any of that, I'm sure he would be hanging around just only working on this Dotty compiler. And the Dotty compiler is getting to a point where it's not production ready, but oh my God, it's getting there. It's a real compiler that's got a real back end that's serious with optimizers and everything else. It's got some new sort of simplifications to the type system. Yeah, it's a full thing. There are some things that need to be changed and added to it, but it's getting really close.
Okay, can you maybe elaborate a bit more about the compiler? Is Scala the syntax changing, or is it just performance optimizations? What's about all this?
So, macroscopically, no, nothing is to most users, not a lot is changing. If you depend a lot on the metaprogramming frameworks, then a lot is going to change because we have a new design for metaprogramming or for macros and things. But otherwise, hypothetically, okay, I know this isn't really the case, but macros and this metaprogramming stuff has always been marked as experimental, which means don't depend on it, it's not production ready. Which meant that we reserve the right to update it or change it. But anything else that wasn't experimental is basically not going to change to the user. Inside of the compiler, the way that it represents certain language features and things, this does change, but it's in a way that should mostly be transparent to the user. There are some small changes to the type system, but if you don't do fancy type system tricks, especially, the data science people tend not to, then this is something you're never going to rub up against. So largely, it shouldn't really be that different to people, especially in the data science community.
And can you contrast Scala to any of the other JVM programming language of your choice, like Kotlin or Clojure or any other than Java?
Can I contrast it? Yeah, but I can. But I guess I'm not sure I have such an intelligent thing to say about it, because I like Scala more than most of the other languages because, well, it has a richer type system than Kotlin, which means you could do maybe, this is not for everybody, but you can do more interesting things with the type system. You can make stronger guarantees about what your program will or will not do. So if you're interested in kind of like the bleeding edge of what's going on in type systems land, of course Scala is a better place to be if you like that stuff. So that's me. That's not everybody. Kotlin has a modest type system that's not as fancy as Scala, so that's one major difference. And of course Scala has syntax, unlike Clojure, which is all parentheses-y.
Yeah.
That's the only thing that Clojure's a great language. Some people can't. No, it is. Just some people cannot do a Lisp, and I'm one of those people. It just gives me a headache.
Yeah, I think you need a huge staging area in your brain, no?
Yeah, exactly. Or you need a really good editor.
Yeah. Okay. I wanted to ask you another question, but actually it popped out of my mind. Just give me 1 second.
It's all good. I'll drink the rest of my coffee.
Sure.
Take your time.
I got it. Okay. What's your opinion about null pointers?
Oh, yeah, well should I say I like them? It's... Okay.
Yeah, maybe how they are handled in Scala and in Kotlin and Java, and what's better, what's worse.
Oh, I don't know. To be honest, I don't think about null pointers very much because I have my nice options in Scala, and many of the primitive types can't be null in Scala. So I have actually very little thought of null pointers just because I don't usually encounter them, and I don't even care very much about what the other languages do because I just don't even think about them in Scala. So it's a solved problem. Next.
Okay. So how is that problem solved in Scala? You have been talking about options. Can you explain options?
Yeah. So you can think of option as like something like a wrapper type. So if there's something that returns a result that you care about, then you wrap it in something of type option. So option has two subtypes. One is sum, which is like something, I don't know, maybe the name is not the best, but it's just a thing that wraps whatever your value is. So if some function should return a number, then if it properly returns a number, then it should be wrapped some 3, and then 3 is the value that it wraps. Whereas if it shouldn't return a value, then you can use none, which is just like an object kind of that is always the same one. And that way you don't have to return null, and you don't end up with null pointer exceptions and all of this. It's just simpler to wrap these things and keep stuff in some or none, basically.
Okay, I think that idea was also copied into Java now, as well as lambdas. Is that true?
Was it?
Yeah, I think so. Yeah, you have options in Java as well now.
Oh, wow.
And lambdas, but
Woo-hoo,
yeah.
I didn't know about the options in Java. That's a great idea. It didn't come from us. This is just something that's been around in functional programming land for a while, so I'm really glad that they adopted it, but I had no idea.
Okay. So Scala is actually helping the Java community. That's nice.
I wouldn't say Scala. So clearly many of the things that happened in Java must have been influenced by Scala, but I'm not going to say, well, if Scala didn't have option, then Java would never have it. I mean, maybe if Scala never existed, some other functional language would have inspired Java to have it. So, it's not like this idea was originated by Scala. But, I don't think Scala should take all the credit, but it certainly probably put some pressure on the Java folks.
Okay. Thanks a lot. I think you really motivated me in taking the next Coursera course. I think, how is it called? It's about monads and all that stuff.
Monads?
Monads, yeah.
Which one?
I think the first one is principles of
functional
programming.
design.
Yeah. Functional programming design. Okay, yeah. So I think I just will take that, the second one.
Yeah.
Okay.
Sounds good.
Thanks so much.
Yeah, thank you.
Okay, bye.